Good morning, sir. Okay, good morning to everyone. So today let us look into the basics of machine learning, data science and some Python libraries which help us to implement the concepts. So today's FDP session is based on Industry 5.0, integration of the new techniques in Industry 5.0. So I think yesterday you would have learned about the basics. So let me refresh it again. The industry of at present we are into Industry 5.0. The origination in 1.0, it was focusing on the mechanical production, water and steam power. So 2.0 in late 80s focused on the division of labor, electrical energy. 3.0 in 90s focused on the electronic and IT systems. In 20th century, the industry 4.0 focused on the mass production, and in 5.0 personalization apart from the mass production. So this is what the history. 1.0 gives the birth to the industrial revolution. So it focused on mechanization, steam power, factory system, impact on society. 2.0, it entered into the era of mass production, which focuses on the electricity, communication, internal combustion engine, mass production assembly line. 3.0 gave the rise of automation, which focused on the computerization, automation, electronics, programmable logical controllers. 4.0 gave the rise to the automation and digitalization. So where into the computer science related concepts like IoT, big data, AI, automation and robotics, digital twins, cloud computing, cyber security, AR, VR, additive manufacturing came into picture. Industry 5.0, the machine started working with the human beings, which focused on the human factor, plant process management, and mass personalization along with sustainability. So there's a future concept which is Industry 6.0, wherein the quantum computing comes into picture. Focus is on quantum computing. So today it's a basic concept. I hope everybody know what is AI. We want to make the machine to think like human beings, like what human beings will do. We'll understand the commands, like how Alexa and Siri is understanding nowadays. So AI can recognize the faces in photos, even in your Facebooks, your friends' faces can be tagged. Even AI can play games like chess, Go, like human being. So today we'll see the basics of terminologies. First, the terminology AI. So it is making the machine to think like the human being. You know who actually coined the term AI? It is John McCarthy. So they have organized a conference in the year 1956. The conference name is Dartmouth Conference. In that conference only, John McCarthy, along with the other researchers, coined the term artificial intelligence. So why John McCarthy is called as the father of AI? Next, machine learning is a subset of AI which will focus on the algorithms, development of the algorithms. So these algorithms will learn from the data and make predictions. So the term machine learning was coined by Arthur Samuel in the year 1959. So indirectly he can be called as the father of machine learning, Arthur Samuel. So regarding the history of AI and ML, it started in the 18th century with the birth of the theorem framed by Bayes, a very famous Bayes theorem, which is nowadays used in most of the learning techniques. So followed by Ada Lovelace. She is a woman who developed the first algorithm. First algorithm, you can Google it. Who's the first person who developed the algorithm? It is Ada Lovelace. She is a woman. She collaborated with Charles Babbage. Charles Babbage worked on an analytical engine. So why he is called as the father of computer science, Charles Babbage. And this is the history in the 18th century. So you can see a meme like why programming is difficult to understand. So if you Google it, you can identify the memes like why programming is difficult now because it was developed by a women. Accordingly, the people will troll. So you try to understand Ada Lovelace is the first woman who developed the algorithm along with Charles Babbage, who is the father of computers. Next, the era from 40s to 50s, Alan Turing, a famous test was developed by Alan, which is called as Turing test. So this Turing test is used to distinguish a human being from a machine and followed by the introduction of the John von Neumann architecture. So this is regarding the 1940s to 50s. And then in 56, as already mentioned in the Dartmouth conference, AI was born by John McCarthy. He is the father of AI. And from 50s to 60s, the logistic theorems were developed. General problem solvers were also developed. And 60s to 70s gave the birth to the expert systems. So a few expert systems are dental expert system, which was developed in 1960s by Stanford University for chemical analysis. And another expert system is MySyn, which is created for diagnosing the bacterial infections and recommending antibiotic treatments in the year 1970s. Next, from 70s to 80s, it was idle period for AI, which we call it as AI winter, because there was no funding to make the AI to have progress. So there was no improvement during 70s to 80s. So when the development of neural network gave rise to the tremendous growth of the terminology artificial intelligence, where researchers showed interest in the development of neural networks, followed by the development of backpropagation algorithm, which laid the foundation for training the neural network. And next, from 90s to 2000, it witnessed a shift towards data-driven approaches in AI and ML because of the availability of the computing power. The two fuel of any ML or AI application is the data and the computing power. So only during the period 1990s to 2000, the computing power were available in a cheaper cost. So algorithms started developing during that period, and 2010 started with the revolution of deep learning algorithms like convolutional neural network for processing the image, detecting the objects, segmenting the images, and recurrent neural network, which can process the speech and do the time series prediction. So from the 21st century onwards, AI has got tremendous growth in the field of healthcare for drug discovery, genomic research, treatment recommendation, disease diagnosis, image analysis, in finance application for credit card fraud detection, risk assessment, customer segmentation and personalization, in the field of automation for autonomous vehicle, and in the entertainment field. So nowadays generative AI is playing a vital role in the entertainment field. So this is small difference between AI and ML. So AI is a broader terminology, whereas ML is a subset of artificial intelligence. Scope of AI, it encompasses a wide range of techniques whereas ML focuses on specific algorithms. With respect to the goal, AI replicate like human intelligence, whereas machine learning enables the machines to automatically learn. With respect to autonomy, AI systems can autonomously work. ML algorithms also can automatically learn from data. With respect to the complexity of problem solving, uncertain environments are faced by AI applications, whereas ML typically focuses on the well-defined problems such as classification, regression, clustering. With respect to cognitive abilities, perception, learning, memory, language understanding, logical reasoning are the prime aspect of AI, whereas the ML primary focus is on learning patterns and relationships. With respect to human-like interaction, ML algorithms do not interact directly with humans, but it process the applications in the background, whereas AI applications directly interact with the humans. Regarding the examples, AI examples are chatbots, virtual assistant, autonomous vehicle expert system, game playing. Applications or examples of AI, ML or image recognition, NLP, recommender system, predictive analytics, and autonomous robot. And you have another terminology called generative AI, so which is the foundation for our chat GPT nowadays we are using it, right? Generative pre-trained transformer. So generative AI is a specialized field of ML. It is used to generate new data. It can synthesize the image, can generate new images. Next comes the prompt engineering. So prompt engineering, it is designing and refining the prompts, especially which is used in natural language processing, which is applied by the large language model, generative pre-trained transformer, which we call it a GPT. So next is prompt engineering. Some certain prompts. This is how prompt engineering works. It will be interesting. Prompt engineering is an interesting field. So large language models allows the user to interact in the form of a prompt with the natural language or spoken language. So here, for example, in Google Gemini, you can type a query. That query you call it as a prompt. So if you type tell a joke, Infosys Springboard. Certification is prompt engineering. So similarly, you can type this prompt here. You type the first prompt alone. In the prompt, you type cat colon. The category of cat is omnivorous. It is four-legged. It is agile. And then you type peacock colon. Just leave space and enter. First prompt alone you type. The last but one prompt you just type peacock or jackal, anything. You got the answer. No, I'll show. Or otherwise I'll show, you need not do it because it will take time. See here, I'm typing entire prompt here. See, look into the screen. So already I've given the answer for the 3 categories and I'm asking the answer for 2 categories. So it is giving peacock belongs to an omnivorous, 2-legged flying and dancing, jackal is a carnivorous, 4-legged hunting and cunning. So if you refine your prompts accordingly, you will get your answers. Similarly, next example of prompt is, for example, I'm giving the brand of the vehicle with respect to the country and I'm asking a new country now, then let us check what it is telling. For example, Germany is for Mercedes-Benz, BMW. It is not allowing me to copy. So let me give another prompt. So I'm giving a paragraph here and I'm asking Gemini to extract the characters from this paragraph. Just a minute. So I'm typing the prompt here. So you can try this later. Just you'll see there, few countries brands have been given already, and we are asking for a new country. So for UK, it is printing it as Jaguar and Aston Martin. Similarly, another query. The query you call it as a prompt here in prompt engineering. So we are giving a paragraph and we are asking, can anyone say what the answer will get from this prompt? We are going to give a paragraph here. This paragraph will contain some characters and the query is extract the names of the characters from this paragraph in a CSV or JSON format. So what output you will expect here? What output you can expect here? See the output, sir. Actually, it is creating a comma separated value format and Java format automatically. See here. So this is the power of giving the prompts. Similarly, you can give, with respect to you are a geologist, to describe the earth in a short paragraph, or you are a mathematician, you are a French teacher. So with respect to the context, the answer to the prompt will differ. So a lot of prompts are there. For example, I'm asking generate two numbers, program to generate two numbers. No syntax. Prompts doesn't have any syntax, only our natural language. See here it is giving the program to add two numbers. If you can specifically say generate a code to add two numbers using Python, accordingly you can give. See here. Now it will give the code in Python. If you wish to convert the above code to Java, see here the above code it is automatically converting to Java. So accordingly we can give our own prompts. So this is the power of prompt engineering. Okay, next is large language model, which is base for ChatGPT. Next terminology is the natural language processing. It is a subfield of AI and ML. It focuses on the interaction between the computers and the human languages. It performs the tasks like text understanding, sentiment analysis, language translation, and speech recognition. So here, discovering the people's opinions, images, and feelings of a product or a service. Next terminology is deep learning. So which has got a lot of algorithms. So deep learning, it performs the task like image recognition, speech recognition, natural language processing, reinforcement learning. Actually, Geoffrey Hinton, he is actually considered as the godfather of deep learning, Geoffrey Hinton. Next terminology is transfer learning. So normally in machine learning, uh, uh, in a normal traditional programming language, we used to give the input and the algorithm, the program will give the output. Whereas in our machine learning, we will give the input and the output, so it will give the model as the output. This is a machine learning concept. There is a concept here called transfer learning, so which is a machine learning technique. So in case of machine terminologies, I'm telling just this is a basic session. You have to understand deep learning because transfer learning has got a lot of models. So in machine learning, we will be building the model from the scratch, which is a time consuming process. So in order to overcome it, there is another terminology called transfer learning. So instead of training the model from the scratch, you can take any of the already trained model and you can customize that model as per your requirement based on your data set. So this is called as transfer learning. So here pre-trained models are there. So normally any data set will have some rows and columns, right? So the columns we call it as the attributes. So the attributes only we will process. So pre-trained model, for example, if you take GPT-3 has been trained on 175 billion features. 175 billion. The features are called as the parameters here. 175 billion parameters have been taken to train the GPT-3 pre-trained model. So here transfer learning, normally feature extraction is one part and classification is another part. in a normal machine learning model. Whereas if you take, you can freeze the feature extraction. You need not again redo the feature extraction. Whereas the classification part alone, you can do replace and retrain. So here you are avoiding the time taking to extract the features. So this is one option. Another option of transfer learning is that feature extraction also partially you can retrain. Classification also you can replace and retrain. So this is a difference between machine learning, deep learning, and transfer learning. So some of the example popular pre-trained models with respect to different domains. For natural language processing, the pre-trained models already available are GPT-4, 3.5, BERT, Robert A, XLNet, T5, Distilbert, Albert. For the task of computer vision, the pre-trained models available are ResNet, which is for image classification, VGG is visual geometry group, which is for again for image classification. Next, efficient net, so which has balanced speed and accuracy. Next is mobile net, it is optimized for mobile devices. Next is YOLO, you look only once, which is used for real-time object detection. Next, faster RCNN, meant for object detection and segmentation. Next, VIT, vision transformer, which is based on transformer classification model. Next is DTR, that is detection transformer, which is used for end-to-end object detection model. So next, coming to the task of speech and audio processing, a lot of pre-trained models are there. Wave to Vector 2.0, Deep Speech, Tacotron 2, Wave Glow, Whisper for speech and audio processing. For reinforcement, the pre-trained models are Alpha 0, DeepQ network, proximal policy optimization, and for multi-model, that is in unimodal, the model will consider either text or image or audio as the output, whereas in multi-model, the algorithm will focus all the data, that is text, image as well as audio. So the pre-trained models available on multi-model models are CLIP, that is constructive language image processing. Next, DALI, stable diffusion, BLIP2. So this is basic terminologies. Now coming to the steps and implement any machine learning algorithm. So we want to develop one machine learning model and we want to deploy it. We want to know how far it is better. That is the accuracy of the model. There are certain steps in implementing any machine learning model. Step number one is, first of all, we need to explore and analyze the data. So we need some data. Based on the data only, we are going to build the model. The data needs to be first analyzed and explored. So conduct an exploratory data analysis to know the insights of the data, and then visualize the data and see how it is, what is the relationship between the different features of the data. This is step number one, exploring and analyzing the data. And after doing all the pre-processing of the data, you select one model. Choose any one machine learning, lot of algorithms are there, right? So choose any one model as you wish, which will best suit for your application. And then you also consider the factors like the complexity of the model, interpretability, and performance metrics. So after selecting a model, we need to take the already processed data, divide the data into training data and testing data. First, train the model, train the selected model using the training data, and then define the problem correctly, whether it is classification, regression, clustering, or any other type of problem. And then gather the data, pre-process, evaluate the model. So for evaluating the model, we have lot of metrics like accuracy, precision, recall, F1 score. If it is a classification technique, if it is a regression technique, lot of error metrics are there. After evaluating the model, deploy the model. After deploying the model, monitor and maintain the model. So a few of the examples of AI applications across different industries are virtual personal assistants, chatbots, recommended system, autonomous vehicle. So we are all aware of these applications: image recognition, NLP, fraud detection, healthcare diagnostics, predictive analytics, and robotics. So we are going to enter into machine learning concept. So this is the mind map of the entire machine learning. So machine learning has got supervised learning, unsupervised learning, reinforcement learning. So if you see, the supervised has the categories regression and classification. Regression has got linear regression and polynomial regression. Classification algorithms are few algorithm examples are logistic regression, decision tree, support vector machine, random forest. Coming to unsupervised learning, you have clustering, association, and dimensionality reduction. Clustering, you have k-means, example, hierarchical clustering. Association, you have a priori, eclat. Dimensionality reduction, you have lot of reduction techniques. Few are given here, principal component analysis and single value decomposition. Next, reinforcement learning has got model based and model free. So, model free learning techniques are Q learning and deep Q learning. Now, coming to the deep learning, which is a subset of machine learning, you have neural network. So, which applies on feed forward neural network. Next, convolutional neural network, recurrent neural network. Again, category of recurrent is long short term memory, gradient recurrent unit, and then transformer models. So, these are all the deep learning models. And coming to the evaluation metric, whatever may be the model we are choosing, we need to evaluate the performance of the model. If the model belongs to the regression problem, so it can be assessed using the metrics like mean square error, root mean square error. If the model is going to do the classification sort of task, then the metrics are accuracy, precision, recall, F1 score, ROC, AUC curves. And next, you have another terminology called feature engineering, which specially focuses on the features. Features are nothing but the attributes of the data set. So you have to extract the features, you have to give the importance, and then you have to scale the features. So for which you have certain normalization techniques. And next, when you build a model and if you feel that the performance is not satisfactory, then you can use certain optimization techniques to improve the performance of the model. So a few of the familiar optimization techniques are gradient descent, stochastic gradient descent, Adam optimizer. So you know well that there are Python frameworks and tools, especially to implement machine learning algorithms. You have scikit-learn and keras. Okay, now few questions based on the introduction given.
Madam, kindly unmute, madam.
Yes, very good. Ada Lovelace developed the first algorithm. Please avoid. Machine learning algorithms. There also questions will arise like this. Please try to listen. Yes. First PPT is over. The basic introduction of terminologies of what is AI, what is ML, what is LLM, what is prompt engineering, what is transfer learning, everything. Now we will enter into the basics of machine learning. And before entering into the machine learning, I'll give an overview of the data science concepts. Okay, so just for 10 minutes, we'll have the introduction of the data science concepts. Okay, just a quick overview of the data science. So, what is data science? Actually, it is collection of various techniques, algorithms, process, and systems. What for it is used now to extract the knowledge, to extract the insights from both the structured and the unstructured data. It combines elements from stats. It requires statistics, computer science, information theory, mathematics, and domain-specific expertise. Why it is required now? It is required for processing the data collected from the various media like social media, IoT devices, and other transaction data. These data need to be processed, for which we need data science tools. So the key components of data science are collecting the data, cleansing the data and pre-processing it, exploring and visualizing the data, analyzing and modeling, interpretation and communication of the results, deployment and monitoring. Now the algorithms and key techniques in data science are statistical analysis is required. The statistical analysis can summarize the data, find the patterns and infer the conclusions. Next, machine learning, which uses the algorithms from the data. Next, natural language processing for analyzing the text and human understanding. Data mining process, deep learning. And types of data science tasks are descriptive. It is capable of doing the descriptive analysis, predictive analysis, descriptive in the sense historical data, predictive in the sense statistical models, and then prescriptive analysis, diagnostic analysis. Next, applications of data science in the field of business, marketing, finance, healthcare, e-commerce, social media. The different tools and technologies in data science are for programming languages like Python, R, and SQL. Data visualization tools like Matplotlib, Seaborn, Tabula, and Power BI. Machine learning libraries we are going to discuss scikit-learn, TensorFlow, and PyTorch. Big data tools like Hadoop, Spark. Data storage and database like SQL, NoSQL. There are certain challenges in data science like privacy, security, quality, interpretability, scalability. These are all the fundamentals. So there is a data science process called CRISP, which is cross-industry standard process for data mining framework, which is a structured approach. First, it focuses on business understanding, data preparation, modeling, evaluation, and deployment. Now, tools and techniques. Data collection tools like APIs and web scraping, database management tools, integration tools, libraries of Python, R libraries, data cleaning platforms. Next, data analysis and statistical techniques involves tools like pandas and Python and base R function for calculating the mean, median, mode, and variance. Next, inferential statistic, SciPy and R packages. Next, EDA, which involves pandas, matplotlib, seaborn. Next, visualization tool involves matplotlib, seaborn, plotly, bokeh. For R library involves ggplot2, shiny, plotly. Visualization platforms involves Tableau and Power BI. Now, machine learning and data mining Python libraries are scikit-learn, TensorFlow, Keras, PyTorch, XGBoost. R libraries are Caret, Random Forest, NNet, and Keras. Hadoop ecosystem involves Hadoop distributed file system, MapReduce, Hive. Now, we'll discuss about the Python libraries, especially Pandas, NumPy, scikit-learn. There are certain version control and collaboration tools like Git, GitHub, GitLab. So we have certain workflow and automation tools. Today we'll be using this Jupyter Notepad. Jupyter Notebook. With the help of this only, we'll execute certain programs. There are certain experiment tracking and model deployment tools like MLflow, TensorBoard, Kubeflow, Sheldon. As I told, these three package libraries of Python we are going to focus today: numerical Python, Pandas, and scikit-learn. So for which there is a small demo sheet. I'll share it to you. You refer it and do the simple exercises using NumPy. So NumPy, basic codes in NumPy. We'll do it in Google Colab. How to create arrays, built-in functions, array operations, mathematical functions, indexing and slicing, reshaping and transposing, broadcasting, how to apply linear algebra operations, certain common use cases, and simple data analysis. Next, using Pandas library, we'll see how to install it, create a data frame, and how to load a CSV file, how to view a data frame, how to summarize it, how to select the data column rows separately, how to filter the data, how to add and modify the columns, how to deal with the missing data. All codings are given here. You can refer it. So for sorting of data, grouping of data, merging and joining the data frames, exploring the data, and this is a simple data analysis example with respect to student marks. Next library of Python is scikit-learn. So here how to import the scikit-learn, how to load the data. And then we told, no, for machine learning, we need the data to be trained and tested. So how to split the data for training and testing, how to train a model, how to make the prediction, how to evaluate the model, how to do the cross validation, and then scaling of the features. Next, a simple clustering k-means, loading the models, a simple classification task using logistic regression, and then hyperparameters. So as we discussed, if the accuracy is not satisfactory, then we can fine tune the hyperparameters so that the accuracy can be improved. It is hyperparameters. So this small document, I'll share it. So now the basics of data science is over. Now coming to the machine learning basics. Machine learning basics. So lot of algorithms are there: supervised, unsupervised, reinforcement. So in this slide, we'll focus only on supervised and unsupervised. I will quickly recall. You can categorize the AI models, that is ML models, into supervised learning. Categorize it as unsupervised, reinforcement. So supervised with the help of a class label, like the output you will say, the output, this is the apple, na? That is a class label for that particular data. Then your model will tell it as either apple or some other fruit. So that category is called as supervised learning. In case of unsupervised learning, no label you will give it. The model will learn on its own without any labeling. So that is called as unsupervised learning. Like we will read some concepts on our own. That category is unsupervised. And then reinforcement, which is based on some reward state action. Another category. First is supervised learning. Some labeled data. It will work on some labeled data. For example, let us take some set of emails and we want to classify the email whether it is a spam mail or a non-spam mail. So the output is a model can classify new email as a spam or a not spam. So another input data containing the data set of house features. So the house features in the sense, what is the size, that is the square feet of the house, how many rooms are there, the location of the house. So these features can be used to predict the house price. So this is another example of supervised learning. And here the entire data we will take. This entire data we will divide it into training, validation and testing. So for example, 1000 data rows are there in the data set. We can take some 800 for training. Normally the normal ratio is 80-20, but the ratio can vary. And few data we can use it for validation. Most of the time validation we are not doing, directly testing and training. But anyway, if you do validation, you can identify which model is the best model. And actually testing helps us to know how good is the model we have developed. So now the concepts here was input features. So first we'll give the features. For example, to predict the price of the house, the features of the house are the square feet, the number of bedrooms and the location of the house are the features. Output labels. In this case, a target, it is called as a target variable, which is nothing but the price of the house is the output variable here. Now training set, subset of the entire data to train the model. Testing set, as we told, to test how good the model is. And validation, you can develop a number of models and then choose which model is best. So this is regarding the concepts of supervised learning. So here another example. You have certain set of currency coins. The problem statement is that build a model to predict the coin based on its weight. So here 4 coins are given and their respective weights are also given here. So euro weight is like 5 grams. Similarly, 4 currency types are given. And here the feature or the attribute is the weight. Attribute is the weight. And label is the currency. Which currency is that? Based on the weight, we have to identify the currency. So features, label, we train the model using supervised learning model. And then for testing, we are giving some new data. For example, 3 grams we are giving. So it is predicting it as $1. Already you checked. See here, 3 grams. If you give, already assume that you have out of the 4 currencies, we have taken 3 currencies, euro, dirham and rupee, and given it for training the model. And for testing, we are using 3 gram. So when you give 3 gram, so it is predicting that it is $1. So now coming to the types of supervised learning, we have regression and classification. So regression works on the continuous input and classification works on discrete input. First is regression. So as we see just now, how to predict the price of the house based on the square feet, area, location. Similarly, how to predict the stock market based on the historical data. So common algorithms under regression are linear regression, polynomial regression, decision tree. Decision tree is also comes under classification. Next category is classification, which works on the categorical data, that is yes or no. Example, email spam, whether the mail is spam or not spam. Next, classification of the image, classifying whether the animal is either a cat or a dog. Okay, so how it works now, it learns from the labeled data. First, we will provide the labels, no, that based on the labels, it starts learning with each input, and then the trained model can be used to classify the new model. Some common algorithms are logistic regression, decision tree, support vector machine. Now the question is, so we have two categories of supervised learning. One is regression, other one is classification. Ah. So we'll have a questionnaire session and then break for tea break. Now the question is, just now I was telling about regression and classification. Regression works on the continuous value, classification works on the discrete value. Now you know what is sentiment analysis, right? Sentiment analysis is identifying the human mindset or the mood of the human being, whether he is happy or unhappy or neutral. Now let me know whether this application sentiment analysis is a classification program or a regression problem. Any answer? Classification. Yes, sir. But uh, can you justify how it is a classification problem? Can you justify?
Madam, kindly unmute, madam.